Welcome to the new video seminar. Here is Dr. Hoffman. Subscribe and give me likes. Let's start now.
The economy can be thought as two cycles moving in opposite directions. In one direction, we see goods and services flowing from individuals to businesses and back again. This represents the idea that as laborers, we go to work to make things or provide services that people want. In the opposite direction, we see money flowing from businesses to households and back again. This represents the income we generate from the work we do, which we use to pay for the things we want. We started with a circle flow model of the market of goods and services and the market of production factors. Both directions of these cycles are necessary to make the economy work. When we buy things, we pay money for them. When we go to work, we make things in exchange for money. The circular flow model of the economy distills the idea outlined in this graph and shows the flow of money and goods and services in a capitalist economy. In these two sectors, simplification, firms supply goods and services which are purchased by households, and households supply production factors which are purchased by firms who need them. They need labor, capital, and land. For labor, they pay back wages. For capital, they pay back interest and profits. And for land, they pay rent. A factor market is a market in which companies buy the factors of production or the resources they need to produce their goods and services. Companies buy these productive resources in return for making payments at factor prices. This market is also referred to as the input market. The goods and services market is where households purchase consumable items and businesses sell their wares. The market includes stores, the internet, and any other place where consumer goods and services are exchanged. In economics, marginal cost, MC, is the change in the total cost that arises when the quantity produced is incremented by 1 unit. In microeconomics, the marginal factor cost, Mcx, is the increment to total cost paid for a factor of production resulting from a 1 unit increase in the amount of the factor employed. It's expressed in currency units per incremental unit of factor of production input, such as labor per unit of time. Marginal revenue product, Mrpx, also known as the marginal value product, is the marginal revenue created due to an addition of 1 unit of resource. The marginal revenue product is calculated by multiplying the marginal physical product, Mpx, of the resource by the marginal revenue, Mr, generated. Marginal revenue, MR, marginal benefit, is a central concept in microeconomics that describes the additional total revenue generated by increasing product sales by 1 unit. For X, you can substitute labor, L, land, A, or capital, K. The price of the product produced by the employee is 100 euros. The total production of the company will increase by 500 pieces when hiring an additional employee. The salary of an additional worker is 30,000 euros. In A, we are asked how will the revenue grow when hiring another worker. For this we use abbreviations. MRPL stands for the growth of revenue when hiring another worker. P is the price of a product produced by an employee. PL is the price of labor. And MPL is the growth of the company's total production when hiring another employee. PL equals MRPL from theory, which is given by formula P times MPL, and that's known from the yellow text above. P is 100 euros, MPL is 500 pieces. That's why MRPL is 50,000 euros. Now we calculated the growth of revenue when hiring another worker. In B part, we should answer the question if the company should hire one more employee. MCL, the cost of hiring another worker, it means his salary, is given in yellow text above at 30,000 euros. By comparing revenues from the sale of products created by another worker, MRPL, with the cost of another employee with his wage, we find that the growth in income exceeds the growth in cost, and it will be optimal for the company to hire an additional worker. So the company does this hiring till MRPL equals MCL. From that point, it wouldn't be more hiring. This is the condition for maximizing profit at the optimal amount of the production factor of labor. When here MRPL is larger than MCL, we say this company should hire an additional employee. The decreasing part of the Mrpx curve is limited by the value of the Arpx maximum and is also from point x2 the company's demand curve for the production factor x. The condition of profit maximization is met for the amount of production factor x3 when the company has the maximum profit. x0 is the maximum loss here. For the part of supply line from x1 to x4, we use the name profit zone for the yellow point. The condition of profit maximization applies MCX equals to MRPX. It means marginal cost of the factor of production equals to marginal revenue of the factor of production. So here you can see the graph of demand for production factor X and supply of production factor X in perfect competition. On the left, there is a graph of supply and demand for perfect competition in both markets. It means the production factor market and the product market. On the right is a graph of supply. Demand can be constructed for imperfect competition in both markets. It has production market and product factor market. Yellow dots indicate a maximum profit in both graphs. The offer for perfect competition, or the supply for perfect competition, is horizontal, parallel to x-axis, and it is identical with the ACX line and MCX line. ACX means average cost of the product factor, and MCX means marginal cost of the production factor. For imperfect competition on the right, it is growing this supply function, identical to the ACX line, no longer MCX. The MCX line is in the right graph separately from the PX ACX line. It is growing faster. It has a higher positive slope. In perfect competition, the demand for factor is expressed by the declining part, just the part of the declining part of the Mrpx marginal product revenue curve. In imperfect competition, on the other hand, the demand for the production factor can't be expressed. There is no fixed price of the production factor. The perfect competition price of the product P and the price of the factor Px are constant. In imperfect competition on the right, the price of the product P and also the price of the factor Px are variable, given by a function. Px increases together with the increasing amount of the supplied production factor x. Therefore, ACX, average cost of the factor, equals TC over X, total cost divided by amount used of the production factor. MRP in perfect competition equals to MP times P, where MP is marginal product and P is the price of the production, and MRP in imperfect competition equals MP times MR, marginal product, times marginal income or marginal revenue. In perfect competition, a firm demands such an amount of factor until its price equals the income from the marginal product of the factor Px is MRP. In imperfect competition, the firm determines the price it will pay to the owners of factor X and hires such a quantity of factor for which MCX equals Mrpx applies. It means the costs that the company will pay for hiring another unit of factor. The production function of the company is expressed in the form Q is 80x minus 4 times x squared. The price of a unit of production is P, 20. The production factor on the market costs Px equals 640 euros. In A, we answer the question what type of competition is in the product market and what is the factor market competition. We have price of factor given as Px equals to 640. It means it is a constant, and this means we have a perfect competition on the market of factors of production. For the other one, the market of goods and services, we used the price P without the index X, which was given as 20. Again, it is a constant and not a function. That's why we say it's a perfect competition on this market when speaking about price of product. P. Let's go to B question. Express the function of the demand for the production factor X. Demand function was Px equals to multiplication P, which stands for price of production or product price, multiplied by Mpx, which stands for marginal product of a factor. It means 20, which is P from the yellow text that was given, multiplied by dq by dx. This is the derivative. Derivative of the given function in the yellow text, 8x minus 4x squared, could be derived, and after you get 80 minus 8x in brackets times 20 is 1600 minus 160x. This is the demand function we were asked for in B. In C part, we are asked for the determination of the amount of production factor at which the company makes the maximum profit. Px is 640 euros. It was given here in yellow text and should equal to 1600 minus 160 times x, which was calculated in B part. So from here you can see x equals to fraction 960 over 160, which is 6. And because x stands for the demanded quantity of the production factor, we say it's 6 pieces, 6 liters, or another units of the production factor. In D, we should determine the amount of production at which the company makes the maximum profit. We will mark this amount of production Q. It is given in yellow text as 80x minus 4 times x squared. We know that x calculated in C part is 6 pieces. That's why we use for this function this x. So we can read that q function for x is 6 makes x 80 times 6 minus 4 times 6 squared, which is 336. In E part, we should determine the amount of economic profit. So I will use in E part the P that stands for economic profit. Then I have TR stands for total revenue minus TCX, which is total cost X of the product X, or production factor X. If you can express TR as P times Q, where P stands for the price of production, which was given as 20, and Q stands for the function 80x minus 4x squared. In this specific case, with x is 6, is 336. The TCX part is expressed here by the purple background like multiplication px times x, where px stands for the price of the production factor, which is given as 640, and x stands for the amount of this factor, which is calculated in C part as 6 pieces. Now we have all the data we need to calculate how much the company makes on profit. It is 6,720 minus 3,840. So total revenue minus total cost, where total revenue is higher than total cost and we really make profit and not loss. The profit is 2,880 euros. And let's go for deeper analysis here find the extreme of the profit function. For this P, we use nearly the same part, but we generalize now and we let here the axis. TR is 20, it is given for P times Q. Q was given as a function, 80x minus 4x squared, so I let it here as a function. TC is given like Px times x. Px is given like 640, and I will add here the x, as we discussed before. Now I have the general expression with x's, which is generally true for this profit in this situation. I can read from here that 1600x minus 80x squared minus 640x makes 960x minus 80x squared, which is the profit function of this company. And I can now search for extreme of this profit function. You know that the extreme is the derivative b by x equals to 0. So, generally speaking, the first derivative of b function should be 0 where there is an extreme. We are, of course, expecting the maximum of this profit function. With numbers, 960 minus 160x should be 0 in that point. From here, x equals to the fraction 960 over 160, which makes 6 pieces of the factor x. This is the extreme, so we have as a company maximum profit when we employ 6 units of the factor. Determine the optimal amount of production factor and product if the price of the production factor Px is 64 plus x, the unit of the final product costs P 6 euros. The production function is given in the form Q equals to 20x minus x squared. In A, we should answer the question, does the company have a monopoly position on the product market? Again, as in the similar situation from the previous example, you know that the price of the factor Px is given by the function and not by a constant. From here I can say there is an imperfect competition on the factor market. And the price of product B is constant, it was 6 euros. That's why we speak about a perfect competition on the market of goods and services. And the company can't have a monopoly position. In B, we are going to determine how high a profit does the company achieve. For this, we need to pre-calculate some parts of the B profit calculation. At first, MCX, which stands for Marginal Cost of Factor. Calculate it like DTC by DX. That is DC like total cost and X like the amount of factor. For this, we know that total cost function equals to Px times X. From here, we need the derivative. Px is 64 plus X It means we look for a derivative of this expression in parentheses, 64x plus x squared. The derivative is 64 plus 2x. And this is the marginal cost MCX. We know that MCX equals to P times Mrpx. So we can write MCX 64 plus 2x equals to 6 times 20 minus 2x, where 6 is the price, and 20 minus 2x is Mrpx. When I use x, when I use equation and calculate step by step to x, I get that x is 4 pieces. Again, here we can also have energy units than pieces, liters, and so on, where x stands for the amount of employed production factor. Q function was given as 20x minus x squared. I will use, instead of x now, the calculated 4 pieces, and I get that for these 4 pieces at this point, the Q function has a value 20 times 4 minus 4 squared, which is 64 pieces. So the company produces 64 pieces of the product. Also could be another units. Profit marked as P equals to TR, total revenue, minus TC, total cost. With green and purple colors, we distinguish the separate parts of this subtraction. P times Q stands for total revenues, and we know both P6 and Q64, and Px times X stands for T6, total cost of the factor, where Px is the price of the factor and X is the amount of the factor. We know both of them. Px is 64 and X is 4 pieces. Together we can write open parentheses 6 times 64 close parentheses minus open brackets open parentheses 64 plus 4 close parentheses times 4 close brackets equals 112 euros together. The function of the demand for the company's production on the monopolistic market is given by the expression P equals 66 minus Q. The price of the production factor is given as Px equals 6. And the production function is given by the expression Q equals to 4 times the square root of x. In a part, we should determine the optimal amount of the production factor. The price of the factor Px is constant because it's given in the yellow text. We know there is a perfect competition on the factor market. The price of product P is given as a function, not as a constant. Again, from the yellow text, we see P equals to 66 minus Q. If it's given like that, we can say that there is imperfect competition on the market of goods and services. A company may have a monopolistic position, it may have another imperfect position like monopoly or oligopoly, of course. And we were asked for calculation in that point. In B part, we should determine the optimal quantity and price of the company's product that the company supplies to the market. We know that total revenue equals to P times Q, where P stands for the price of the production of the company and Q stands for the amount of the production. Here it's given as the expression 4 times the square root of x. So for P, we can supply 66 minus Q, which was given. We let the Q part here, times Q, and it equals 66 Q minus Q squared. The other value we need is the marginal revenue, equals to dTR by dQ, which is the first derivative of the function 66q minus q squared. So it is the first derivative of open parentheses 66q minus q squared close parentheses. It makes 66 minus 2q. Mrpx, marginal product of the vector x, equals to dq by dx, which means the first derivative of open parentheses 4 times the square root of x, close parentheses, prime, equals 4 times fraction 1/2 times x to the power of minus 1/2 equals 2 over the square root of x. As we know that px is the multiplication MR, marginal revenue, times Mrpx, marginal product of x, we can supply. Px is given in the yellow text below as above, as 6. Green part stands for marginal revenue. Red part stands for marginal product of the vector. Now we have the expression 6 equals to open brackets 66 minus open parentheses 2 times 4 the square root of x close parentheses close brackets times, now the part for Mrpx, 2 over the square root of x. We can simplify this as 22 times square root of x equals to 132. And from here, if I divide this equation by 22, I get that the square root of x is 132 over 22, which makes 6. And I can say for which 6 is the square root of x? 6, it is for x 36. And now we get the portion of units we need to produce by the maximum profit, we will produce 36 pieces. Q is 4 times the square root of x. It was given, we didn't have to calculate this Q, and we calculated x like 36 pieces or units, and I supply this x to this expression. It means 4 times 6 makes 24 pieces or units of production. So you see the Q, total production 24 units, is produced by X, 36 units of vector. We also know from the yellow text above that P is 66 minus Q, because we are asked in B part also for the price of the company's product. We supply the calculated quantity 24 pieces in this P function, which means 66 minus 24, and we get 42 euros. And the last part is the profit. We already know TR part is P times Q and TCX part is PX times X. I supply 42 times 24 minus 6 times 36, which makes 1008 minus 216, and the profit of this company is 792 euros. And I can also search for extreme of the profit function, which is the derivative of P function over X equals to 0 point. This point is 132 over the square root of X minus 22 equals 0. It is 132 equals to 22 times the square root of X. From here 6 equals to square root of X, and X is 36. I got the same X value like in B part, so we know this is the maximum profit this company in this situation can achieve. The production function of the company is given by the relation Q equals 6x. The product demand function has the form P equals 120 minus 3Q. The price of the production factor is given by the function Px equals 54 plus 3x. In A part, we are asked to calculate, or let's derive, comment about perfect competitive or imperfect competitive market. You already know the strategy how to distinguish those two from the yellow text. You see there Px is a function. From here I can speak about imperfect competition in the market of production factors. And the price of the product P is not a constant, but it is given by the function. From here also in the market of goods and services we have the imperfect competition. In B part we should determine the optimal amount of production factor that the company will acquire and the price per unit. At first we should calculate TCX, which is Px times X. The Px part is given in the yellow text like 54 plus 3x, and we multiply this in brackets times x, which is given in the formula. We multiply the bracket by x and we get 54x plus 3x squared. From here I can say, because I know total cost, that the first derivative of total cost is MCX, which is marginal cost of the factor. The first derivative of the expression 54x plus 3x squared is 54 plus 6x. Now I know marginal cost and total cost. I also need total revenue. We know that total revenue is calculated like P, price of the product, times Q, which is quantity produced. So for P, I supply 120 minus 3Q from the yellow text below, above, times Q. Q is let as it is. And in the second phase, I again multiply the round brackets or parentheses expression, and I get 120Q minus 3Q squared. From here, because I just calculated TR, total revenues, I use the first derivative of TR and get MR, marginal revenues. As usually, when I derive the total function, I always get marginal function. From 120Q minus 3Q squared, the derivative is 120 minus 6Q. Now I have marginal cost, I have marginal revenue, and I will also need Mrpx, marginal product of the factor, which is calculated like dq over dx. We can read it also dq by dx. It's nothing else than a first derivative of open parentheses 6x close parentheses, which is 6. Marginal cost of the factor MCX equals to marginal revenue times marginal product of the factor. So MCX is supplied by the pre-calculated expression open parentheses 54 plus 6x close parentheses equals MR times Mrpx. For MR I supply open parentheses 120 minus 6Q closed parentheses. For Mrpx I supply 6 pre-calculated here. It makes open parentheses 54 plus 6x close parentheses equals open brackets 120 minus 6 times open parentheses 6x closed parentheses closed brackets times 6. From here x equals 666 over 222, which means 3 units or 3 pieces of the production factor. And this is the answer, half of the answer for B part. The other half, what will be the price per unit? This is given as Px by the expression 54 plus 3x. We supply x3 pre-calculated above, and we get 54 plus 3 times 3 is 63 euros. This is the price of the factor. So this company buys 3 units of the factor, or 3 pieces, for 63 euros. And the price, because we are on the imperfect competition, is created by the company, even if it is purchased factor from the households, but the firm is now creating the price or setting the price, the market. C part. Determine the optimal amount of the final product that the company will offer in the market. So the Q, the amount of the product, is given in the yellow text by expression 6x. I just supply the pre-calculated x3 pieces and I get 6 times 3, 18 pieces or 18 units to production. Now we can read that for 3 pieces of a factor x by 63 euros, I am able as a company to make 18 pieces of the product. In D part, I'm asked at what price will the company sell its product on the market. Price is given as the expression 120 minus 3q. I just supply the q from C part 18 units and calculate 120 minus 3 times 18 and I get 66 euros. And now, similarly to previous examples, in E part, what economic profit will the company achieve? Profit P is given by the formula TR, total revenue, minus TCX, total cost to the factor. Total revenue is represented in the first parentheses like P times Q, minus total cost X is represented by this other parentheses Px times X. When I supply the numbers, which I get in previous points A to D, I have P66, Q18, Px 54 plus 3 times 3, and X 3. From here, 1188 minus 189 equals to 999 euros, and this is the level of the profit of this company. So we can read backwards that we make the profit nearly 1000 euros without 1 euro when we sell our product for 66 euros. We sell 18 and produce 18 pieces of the product. We buy the factors for this production at 63 euros by 3 pieces.
At the end, there is just to say subscribe and give me likes. See you soon.